is everything is here, but still that network is prone to the attacks because it is sitting in the internet. We installed a firewall before that as well, so any threats can be treated there. But that is what we call as a parameter, or data center firewall. We have two firewalls. So the firewall that sits outside DMZ we call it normally as a parameter, and that sits inside we call them as a data center firewall. So this is the normal implementation of DMZ. Now we are bringing that DMZ into uh, normal IT OT environment as well. So from IT, if we have to go to OT, we have created a you can say a DMZ. Now here you have seen the data historian was sitting inside IT network. But now we have taken it out, and we have, of course, that data historian from the ICS attacks point of view is a focal point of getting in attacks. So we don't want any such thing that is vulnerable to be placed inside an IT network as well, because IT network has more risks. So we have taken out that data historian machine and we have put it into a DMZ. We have connected firewall in between. Here we have removed the router. Why we have removed the router? Because now the PLC devices, they know that the firewall, it will route the data to the data historian himself. It does not need a router to tell to go to this network. And there's a data historian there, and you need to save these logs files there. So in this implementation, we have introduced a DMZ. Now, DMZ has a different work from
Welcome to Global Information Security Society for Professionals of Pakistan.
long process. If you have your electricity issues, you have to go to a certain guy who will, come and see and all that. So this is how this modern ICS we are benefiting from. But every implementation has a certain cost, and the cost comes with the security. Whatever we apply modernization to this industrial system, there are a lot of threats that are coming in. So next we will move to IT and OT. So there's a very thin line between IT and OT. If you talk about operational technology, and if you talk about IT, so technically OT is also in IT, but why there's a difference? The equipment or the things that become part of process are called as operational technology or OT devices. Like the intent, it has been written like intent and operation of OT and IT networks are very different. OT systems require real-time data because they don't have any storage, they don't have any they can process or hold something, and then they can, okay, there might be like some small storage available on it, but they work on real time. If it's a device, if it receives one, it will go right. If a device receives zero, it will go left. So this is, they work on like real, but IT networks, they don't work on real data. Network, if you have a congestion, okay, a site will open slowly. But if a OT device, it has like congestion, it will not work. It don't know how to work. So, and the most bigger difference, if you talk about the governance thing, so the OT network is about availability, integrity, and confidentiality. You see the flow: availability, integrity, and confidentiality. In OT, confidentiality is the last thing that comes. Availability is the first, integrity is the second, and confidentiality is the third. So it doesn't mean that we can bypass or we can leverage the confidentiality thing. The importance is there, but availability is the most important thing. That device should work at first. The data that it has received has a strong integrity things, And confidentiality, it can come as a last. But in the IT networks, confidentiality, it comes first. CIA. A lot of people just pronounce it, without any, flow preferences. But, the way it pronounced is how you provide that control the importance. Like in IT, confidentiality is the first thing, followed by the integrity and then availability. So when this IT OT work, and if you see that, so the confidentiality is the common thing, that is, when the connection is there, and the availability towards OT is the higher significance, and IT, it's the lower significance. So this is the main difference between IT and OT if we have to make it understand from the governance perspective. So how this IT and OT workstation connects, like before we have seen a certain diagram where, data historian was there collecting data from the PLC devices. And then we have engineering workstation who are providing commands to the PLC devices. And then we have like sensors, what I told, there are certain sensors, they are prefabricated devices that are installed on, PLC board. And they either receive 1, 0 or certain data in the form of a segment, and they then perform something. So this IT OT integration, it works like same. We have on the local LAN, we have connected these data historians. We have connected this workstation that we can see the data coming out. Now we are bringing in the security devices and connecting both these corporate network and the PLC network. What is the role of firewall? These are not simple firewalls that we use in our normal IT implementation. These are like some use-based firewalls that we can call purpose-built devices. So these firewalls, they are not, they have the same functionality. Okay, they provide the deep packet inspection thing. They will provide you the blockage of certain things. You can implement the policies on it. You can do what normal firewall does, but since they are interacting with OT network as well and the IT network as well, so they have a different fabrication in terms of a build, and they are purpose-built firewalls for the OT. These firewalls, if we go and if we will ask our vendors, they can provide you more details on these OT-based firewalls. If you're into this ICS security implementation things, the network teams, they must get to the vendors, and they can just ask them to provide certain information. So now we will discuss about the ISA and ISA. What is ISA? It's an international society that provides the standard for security and automation of these system. International Systems Automation is the name, and they have a standard as ISA 95. So they have certain levels. When we talk about the IT OT integration, they have like these 4 levels. What these 4 levels are, we'll go through one by one. So at level 0, level 1, and level 2, level 0, we talk about physical protection. Level 1, we talk about process sensing and manipulation, what the sensors are providing the data and how they are being manipulated. In level 2, we talk about automated control of the production process. Level 3, we discuss the workflow. And then at level 4, we discuss about the basic plant scheduling. So this is a whole pictorial view of this ISA 95 architecture that provides how IT OT integration happens. At level 0, you can see we are discussing about the processes, the physical processes that's happening on the PLC. In level 1, we are discussing the devices that are part of PLC, sensors, actuators, PLC, RTU, these all devices. And at the level 2, we are talking about a supervisory control system. Supervisory control system, the data historian, workstation, normally devices called the SCADA or the supervisory workstations or the servers. Then on now here we are getting out from OT and we are not entering into IT. So at level 3, we are discussing about manufacturing operations and the management thing. From here, we have a domain controller, we have like application servers, we have like automation directory. What automation directory is basically controlling all the processes, storing all the processes, how they work, and the data coming out from these devices is matched from this automation directory. And then we get out from this network, the level 3, we get into level 4, bypassing the firewall. Here is the place where firewall is being placed. And once again, I will tell you that these are purpose-built firewalls. These are not normal firewalls that we are seeing on the other end. So the firewall that is here is totally different as equipment from the firewall that is on the other end if we are as we are leaving level 3 and getting into level 4. So until here, we have covered the basic components of ICS, what they are, how they connect, what they send in between each other, how the data is being traveled among them, and where is the point where OT leaves and get into certain IT elements and how they interact, what technology they use. Normally, if we talk about the connectivity, the cabling and all these standards, they are same. If you're using switch, they're all the same. But from the firewall perspective, we have a different devices than from the IT thing. So now we will talk about safety instrument system. They are also very important in terms of industrial control systems. As of now, we have discussed the devices that are performing the core operations of industrialization as a manufacturing unit, as a power sector, as a water utility thing. Things are working in an automated manner. So we have covered only ICS, but together with ICS, there comes as SIS, that is called as Safety Instrument System. These are the instruments that act upon ICS and they provide them a security so any malfunctioning can be controlled then and there. So if these safety instrument systems, if you corrupt them, if you if you remove their programming or you change their parameters, so any malfunctioning cannot be controlled. Like if I take a simple example of data center. So in data center, we have, okay, if the certain rack reaches certain temperature, shut down the servers or intimate the administrator. Now, the thing that I have said, intimate the administrator is a safety working. Raising an alarm, sending an alert is a safety implementation. So we have this with all the industrial control systems. So every industrial control system, parcel in, parcel out is SIS. And together they are called as integrated control and safety system. Like ICS and SIS when combined together, they called as integrated control and safety system. He's working as well, that system, and that system is controlling on any safety parameters. So how it works, how we configure this SIS is through analysis, which is we called as process hazard analysis. The process hazard analysis is very important document when we go through any ICS or OT implementation, because we have to see what are the parameters that needs to be controlled. So and what are the devices that are providing that security? These devices are security for the ICS first before bringing in the IT security. But this is the OT security for the ICS. So if we don't know the parameters, we cannot control them. And as in cybersecurity, we need to evaluate these factors as well. And we need to ensure the integrity of these devices, the availability of these devices. Like I said, AIC. So the AIC is also applicable on this SIS as well. So we do this study, which is called as HAZOP, Hazard and Operability Study, that we perform. And the process is called as PHA, Process Hazard Analysis, and it provides a set of controls that, okay, these are the values that should be configured in SIS. Like I talk about data center temperature. Okay, you will provide me a certain value of a temperature. Okay, 21 degrees centigrade. If it reaches this and Iraq reaches this, turn on this process. If it reaches 24, turn on this step. So, every action has been taken on certain parameters. So if I corrupt a process and I'll go and I'll say to that typical controller, okay, on 28 degrees, send alert to sitting guy in the monitoring unit. So it will be too late. So I need to protect those values as well. So for that, we have safety instrumented functions. Those are the processes that safeguard the values from the HAZOP. Those come from the IEC 61508, 61511, and the ISA standard 84 that defines what are the basic safety integrity level, which has to be achieved. Like if I'm saying it, if I need to say, okay, data center controlling temperature on 21 degrees, so it has to come from certain standard that, okay, we are maintaining this standard. So we get these values from these standards. So we call them as SIL, safety instrumented level. So what happens is on SIL 1, we say that it is the highest probability that system will fail to perform properly. As if it reaches to level 1, we say that system will fail. Similarly, we go to level 2, we go to level 3, and we go to level 4. Level 4 is the level that system probability that a system will fail to perform properly. This is lowest probability. So every device, every SIS function working at SIL4, we consider it as fine. So we define certain values that we extract from the standard, and we say, okay, these are the levels. If these level goes up and down, we perform certain actions. Now, the devices, the equipment who are performing these actions are called as certain acronym. They can be like a lot of different devices, but normally they are called as USD, unit safety shutdown. It will provide the shutdown, process shutdown. In die unit, it will shut down certain process. Emergency shutdown, whole supply chain is working and, there's an emergency shutdown, it will shut down anything. So normally, like if it's providing a shutdown, it will provide also a restoration mechanism as well. So all the SIS equipment, they have like fail safe. Fail safe is okay, shut down this device, and fail secure means they can turn on these devices to turn back to work normally after removing anything. Okay, the automation has worked at that level that it has reduced the flaw by itself, and now it has sent the instruction to that device. Okay, now the issue has been restored. Now you can work. So the SIS equipment, they have these features as well. And then they have a controller feature, that they can send certain data to someone computers, certain mobile phones, or they can place an automated call and all these. So they can also communicate if anything happened, a sensor information received, something bad has happened. It will ask shutdown unit to shut down that process or entire unit or the entire plant. It will be shut down and it will be communicated to the team who is sitting in the monitoring room. Or if there's no monitoring room, it will send to their mobile phones, message, whatever it has to be done. And even it can call the emergency services as well, like fire erupted, God forbid, in a certain plant, it will call to the fire services, it will call to the emergency services and all that. So they can come as in that emergency has occurred. So that SIS equipment has that feature as well. Okay, so as of now, we have discussed about the entire ICS thing, what SCADA is, what is the supervisory control and the data acquisition thing, why they are important, what is a part of that process. I would like to excuse on that because I'm going with a really fast pace, and I hope you must be getting a lot of questions here. But since time is a critical thing, so and we have a lot to cover as well. And inshallah, if it will be, we'll think to go into more sessions so we can have an entire serial of these ICS and OT security. So now we will discuss about how to implement security in this industrial control architecture. So like normal, normal IT network, when we talk about security, we do a lot of things. We do network segmentation, we do zoning, we do segregation of certain network that no anyone outside that network cannot get into it. Closed networks as well. So similarly is with this ICS as well, the ICS security as well. So boundary protection is the first thing that comes in our mind when we have to secure something. So boundary protection is like we introduce gateways, we install routers, we install firewalls, intrusion detection. If someone is trying to bypass those firewall rules or routers, things, so the IDS comes around and he raises an alert. The VLAN thing, encryption, tunneling, antivirus, anti-malware, and it. I think someone is asking for remote control of my screen.
हाँ आप इग्नोर करते हैं, आप कंटिन्यू करें, मैं देख लेता हूँ.
Oh, so ignore. So the boundary protection is also applicable in the ICS implementation. We have DMZs, we have proxies, we have routers implementation, and we use the antivirus, anti-malware products that are specific for the OT devices. We have a lot of scanners that scan the vulnerabilities inside the OTs. They can give us any patches missing, any security update missing on certain OT device, and they can provide us whatever we used to get in normal IT security implementation for the security. So, like I said, firewall. So normally this is a typical implementation of a firewall that we build a block between internet and our corporate network, which is segregated. So, all the traffic coming and going in can be inspected, can be blocked, or, can be filtered to see any anonymous thing or any malicious thing. So in the OT environments as well, so these firewalls have been introduced as we have discussed before. But here we have a certain segment that I told that we have a separate device. Why separate device? Because we have a function which is called as a data diode, which we will discuss further. That data diode is a thing that decides, okay, data can come in one direction, either it can come or it can go. It cannot come and go in the same way. That provides a security, if that's a security arrangement, like if data is coming, it will only be allowed to go. If data is coming out from device, it will be only taken out from the device. So if any malicious thing has been injected, so the outflow can be blocked, we can do the deep packet inspection from the data diodes and you can have these inspected. So normally, when we talk about firewall rules, we build a lot of firewall rules on firewall, and we do deep packet inspection, these kind of a thing. So similar features, they are attained on these firewalls as well. We can build another boundary protection by introducing from the IT network. We can bring a router, and from the OT network we can build a firewall there, so that firewall and router, they can connect to each other, and then it can go to like IT networks router, which can go to its switch, and then we can place some part of OT network like data historian. In this picture, you see that data historian is not in OT environment, it is in the IT environment, which is an unusual implementation of OT network. Usually, data historian is part of OT network, but here we have taken it out and we have kept it in IT network. So any PLC sending data to data historian will come to firewall, and now it will go to router, and router knows where to send this data. It will say, okay, go to this data historian and keep this data. What security it will provide? It will provide if some data is, getting corrupted from in data historian, they can be treated. Now, because data historian is important, logs are important. If your logs are corrupted, if your logs cannot tell you anything about what's happening around, so your logs are meaningless. So now here in this arrangement, we have taken out the data historian, placed it in the IT network, installed a router so it can guide data where to go. And firewall is doing deep packet inspection on the data that is getting out from the PLCs and the controller server is inside, because we cannot control from the outside, because it will provide a very 2-3 legs, network legs will be there, and that PLC, like we said, availability is the main thing. So we have to ensure the controller server is on the same network. It is not on the network crossing the firewall, crossing the router, and going into a separate network. So while OT security implementation, we have to see availability as the first aspect. We will not see confidentiality as a first aspect. That is the main, that is the most important concept. If we go from IT security to OT security, the thing that we have to install in our mind is we have to think from availability aspect. That okay, whatever the control I am introducing, it will not affect the availability. It has to provide the fastest availability. Otherwise, the plant might not work properly. So this is a normal implementation of a DMZ network that we, for certain servers that has to be exposed to the internet, we bring in an environment that has a purpose to get attacked. Security, hardening, everything is there, everything is here, but still that network is prone to the attacks because it is sitting in the internet. We installed a firewall before that as well. So, any, threats can be treated there, but that is, what we call as a parameter, or, data center firewall. We have two firewalls. So the firewall that sits outside DMZ, we call it normally as a parameter, and that sits inside, we call them as a data center firewall. So this is the normal implementation of DMZ. Now we are bringing that DMZ into normal IT OT environment as well. So from IT, if we have to go to OT, we have created you can say a DMZ. Now here you have seen the data historian was sitting inside IT network. But now we have taken it out, and we have, because that data historian from the ICS attacks point of view is a focal point of getting in attacks. So we don't want any such thing that is vulnerable to be placed inside an IT network as well, because IT network has more risks. So we have taken out that data historian machine and we have put it into a DMZ. We have connected firewall in between. Here we have removed the router. Why we have removed the router? Because now the PLC devices, they know that the firewall, it will route the data to the data historian himself. It does not need a router to tell to go to this network and there's a data historian there and you need to save these logs files there. So in this implementation, we have introduced a DMZ. Now, DMZ has a different work from this figure. It is a normal corporate network. Web servers are there, email server is there, any website if you host, it is there. But for the IT/OT, we have brought in another DMZ, which is holding servers that are part of OT network, but has to be kept outside to provide, a kind of a security, a kind of a boundary protection. And this is like same implementation. Okay, now there comes a concept of a proxy servers as well. Like what proxy servers used to do with a corporate network, they can provide the same functionality in terms of OT security. What's the main purpose of proxy server in normal IT environment? That it is a barrier that prevents the outsider from entering into local area network and prevents insider for directly connecting to the outside resources. That's the use of proxy. Normally, we used to interact with internet proxy servers to control people using internet inside an organization. If I don't want to allow any website to be viewed inside my organization, I will simply block it in a proxy, and I will take a hard line on all computers that they have to go through a proxy. Otherwise, there will be no internet. So the proxy thing is there to control use of resources or use of providing some whitelisting, some blacklisting and all that. We use this proxy server. In the OT environment, this proxy server provides a defense in depth strategy. By what proxy filtering is, it's a more complex process than packet filtering, right? During this filtering process, each packet is being disassembled, evaluated, reassembled, making that it is of proper use, and that definitely slows down the process. But here in OT environment, we cannot touch this availability thing. So these proxy filters or the firewalls that are configured to view the entire packet for consistency, or appropriate ports are being accessed, we provide the basic rules to ensure that if you are taking certain data to the data historian,